Hello, I am Dr. Sudha from Government Science College, Autonomous, Bengaluru. In this session, let us discuss differential equations which are reducible to exact differential equations. So, a differential equation which is not exact can be made exact by multiplying by a suitable factor called an integrating factor. So let us look into the rules for finding integrating factors of the equation m dx plus n dy equal to 0. So there are many types. One of them is integrating factor found by inspection. In this session, we are going to discuss integrating factor found by inspection. There are integrating factors of a homogeneous equation. Integrating factor for a equation of the type f1 of x comma y into y dx plus f2 of x comma y into x dy equal to 0. For the equation m dx plus n dy equal to 0, other than the above types, for the equation of the type x power a into y power b into my dx plus nx dy plus x to the power of a dash y to the power of b dash into m dash y dx plus n dash x dy equal to 0. Now let us see the integrating factors found by inspection. The following are some of the combinations which are useful. So whenever we have x dy plus y dx, we can write that as derivative of x into y. X dy minus y dx divided by x square can be written as derivative of y by x. X dy minus y dx divided by xy can be written as derivative, that is d of log of y by x. We also have x dy minus y dx divided by y square, and that is minus of d of x by y. Here we can see in this second one, that is x dy minus y dx divided by x square gives us d of y by x, whereas x dy minus y dx divided by y square gives us minus d of x by y. X dy minus y dx divided by x square plus y square is d of tan inverse of y by x. X dx plus y dy divided by x square plus y square is d of half of log of x square plus y square. Similarly, on practicing, we can form many other combinations which can be used while solving the problems, that is by finding the integrating factor by inspection. So let us see some of the examples. Solve y into y dash square, y into y square plus 1 into dx plus x into y square minus 1 into dy equal to 0. So the solution is, given equation is y into y square plus 1 into dx plus x into y square minus 1 into dy equal to 0. So this can be written as y into dx. So here when you multiply y into 1 dx, we get y dx. Similarly here from the second term we get minus x dy. And here we have y square, and here also we have y square. Removing y square common, we get y dx plus x dy equal to 0. So now let us bring it to one of the combinations which we discussed earlier. So for that, let us divide by y square. When we divide by y square, we get y dx minus x dy divided by y square. And in this term, when we divide by y square will get cancelled and we get y dx plus x dy equal to 0. So what is this? This is nothing but d of x by y. And this term within the brackets here is nothing but d of xy. So we can write this first term as d of x by y and the second term as d of x into y equal to 0. So now to find the solution, let us integrate. When we integrate, we know that differentiation and integration will get cancelled here and we get x by y and plus xy equal to c, where c is the constant of integration, and this is the required solution of the given differential equation. Next, let us solve one more example. X dx is equal to y into x square plus y square minus 1 into dy. The solution is, consider the given differential equation, that is x dx is equal to y into x square plus y square minus 1 into dy. So now let us multiply by dy and y. On the right hand side, we get y into x square plus y square into dy. You retain this as it is. And minus y into dy. So in the next step, let us shift this minus y dy to the left hand side. We get x dx plus y dy equal to y into x square plus y square into dy. Now let us divide by x square plus y square. Y x square plus y square, here we have dy. So here we have y dy can be integrated. So let us divide by x square plus y square to bring one of the combination which we have earlierly discussed. So you get x dx plus y dy divided by x square plus y square is equal to y dy. Now let us write the left hand side as 2x dx plus 2y dy divided by x square plus y square by multiplying by 2. So similarly, let us multiply by 2 on the right hand side to get 2y dy. Why we did this is because we can write this as d of log of x square plus y square. Suppose if we did not multiply by 2, then we need to write half log of x square plus y square. Since we have multiplied by 2, we can write d of log of x square plus y square. And on the right hand side, this is nothing but the derivative of y square with respect to y. So we get d of y square. So we have written both left hand side and right hand side as a derivative of some function. Now let us integrate. So when we integrate, differentiation will get cancelled and we get log of x square plus y square is equal to y square plus c, a constant of integration. And this is the required solution of the given differential equation. Consider one more example. Solve y into 2xy plus 1 into dx minus x dy equal to 0. So consider the given differential equation y into 2xy plus 1 into dx minus x dy equal to 0. Now let us divide by y square. When we divide by y square, we get y into 2xy plus 1 by y square dx minus x by y square dy equal to 0. Let us cancel out 1 by here. and one more y within the bracket you have. So y square divided by y square will get 2x dx. Next, when we multiply the second term, we get y by y square. So we get 1 by y dx minus x by y square dy equal to 0. In the next step, let us combine these two terms, that is the second and the third term, by taking LCM y square. So we get y dx minus x dy divided by y square equal to 0. So the first term can be written as d of x square. And the second term gives us the combination d of x by y equal to 0. So we have written both the terms as derivative of some function. Now let us integrate to obtain x square plus x by y equal to c, where c is a constant of integration, and this is the required solution. Consider one more example. Solve y into x square plus y square minus 1 into dx plus x into x square plus y square plus 1 into dy equal to 0. So we have considered the given differential equation. Let us take the term which is containing x square plus y square as a common. So we have y into dx, so y dx. Here you have x square plus y square, remove that common. So you're left with x into dy. So we get x square plus y square into y dx plus x dy. The remaining term here is minus y dx, and here it is plus x dy. So x dy minus y dx equal to 0. Now to bring it to the combinations required, let us divide by x square plus y square. So when we divide by x square plus y square, in the first term we get y dx plus x dy, and the second term gives us x dy minus y dx divided by x square plus y square equal to 0. So the term within the first bracket can be written as d of xy, and the second term can be written as d of tan inverse of y by x equal to 0. So we have written both the terms as derivative of some function. Now let us integrate. So on integrating we get xy plus tan inverse of y by x is equal to c, where c is the constant of integration. So we can bring the given differential equation to the expression wherein each term is written as derivative of some function. After that, we integrate and we obtain the required solution of the given differential equation. Thank you.